Okay, so this is building query / sprint e demo social distancing edition for March 13th. We're fresh off of workshop and demo at School of Data, so we might do a little bit of redux of kind of what we've covered there. I also think there's some folks here who are taking an interest in query based on how it might support their work for modeling out the coronavirus outbreak growth. So if we can get that confirmed, we can hear from those folks and maybe demo some of what query does and can do and can't quite do. Otherwise, we're here for the community that shows up. So Kelsey had identified a potential use case for queries, so we'll talk about that as well. Kind of also on the generic agenda was showing off the latest version of the differ, since that was just something we sort of hinted at School of Data, and profiling some data stories that our community has contributed in the last week or two, so from Christos and the work Rusty's been doing. So that's quite a bit. Do we want to start with just an 040 demo, generic demo? Okay, great. Then I will turn it over to Chris, and I'll keep an eye on the participants and make sure we're adding people who join.
Keep an eye on them.
Yeah.
They're a rowdy bunch. Okay. How's it going, everybody? I would love to do a demo for you of Qri 040. Basically the same demo we did at School of Data, which was this last Saturday. Awesome event. I'll kind of tone it down a little bit and, I'll kind of speed it up a little bit because you're probably familiar with this project, but basically without, did we even show these slides? Yeah, anyway, Qri's conceptual model. So we're, as you know, version control system, peer-to-peer network, and a database. So we're kind of somewhere in the middle of all these three things to give you more flexibility with not only munging and working with data, but sharing it, and basically turning from federated data sharing where, large resource entities publish and everybody else consumes, and it's not really a two-way street, into this sort of leveling action where publishing and consuming of data sets are equal. It's just as easy to share as it was to consume a data set. And then we like to cover this conceptual model, the data set model before we go into the demo, just because it's important to understand when we say body, we're talking about a table of data. Meta and README are all things that are complementary to the body, but they all really live together under what you would think of as the same document model. So we're kind of adding to data and saying it's not just the data itself, but it's all the other things that you normally leave on the server when you download data, and they all get versioned together and they ride together. So without further ado, I'll fire up Qri Desktop 040. And while that's loading, I've already registered with an account here, so I can sign in and see a collection view that has no data sets in it. So what we're going to do today is actually create a new data set using this button. Actually, we might not use the button. We may drag and drop it. But generally speaking, if you want to create a new query data set, you will start with an existing file-based data, which would be a CSV. And to do that, I'm going to actually go to the New York City Open Data Portal and download this very simple and very small CSV of business improvement districts. These are basically like local government entities that work with businesses in an area, and they'll do street infrastructure improvements, and they'll do they'll manage some of the public space in a retail corridor. So if I export a CSV of this from the New York City Open Data Portal, I end up with this file called Directory of Business Improvement Districts. I'm going to throw that on my desktop with big fat icons so everyone can see them. And let's go back to Qri Desktop. And so in this collection view, which is basically a view of all the data sets I have locally, which again, I have none, I can drag and drop a CSV. So there's my drop zone. And as soon as I let go, it's going to import and infer column types from the CSV. And you can see it dropped us right into dataset view. So before I explore dataset view, I can go back to collection view, and you'll see that there's indeed one dataset now in my collection here. It's called SOD_demo2, which is my username for this demo, and then directory of business improvement, which is basically inferred from the file name. So I can change that later. But back here in dataset view is where we can actually start crafting this dataset. And it's important to understand the context here of history. Basically, we have one version now of this dataset. Qri has inferred the column types, and it has made a commit on our behalf. And then the commit message for that commit is created dataset. So we can explore what happened in this commit, because the UI here is actually telling us which components were created during this action. So we have a body component that is green with a green light here. So that means it was added during that commit. And we also have a structure component that was added during that commit. So I can explore the table here and just look at the values that are in it. I can also take a look at structure and see how it came up with, it read the header row. It's now come up with column names and inferred their types. So we've got integers and strings in this data set. So that's all well and good. And now we have a canonical version with a hash for when this data set was just dragged in. So this is effectively the Qri's view of this data set as it was downloaded from the Open Data Portal. But now we want to start adding value and doing things that you can only do in Qri. So let's click on status over here, and we can now actually start adding new components that don't already exist. So the first thing we can do is add a README, and this supports Markdown. So it's similar if you've ever worked with GitHub. I can call this directory business improvement districts, and just leave sort of freeform text to help people understand why I care about this data set. I downloaded this and want to add some additional columns to it, for example, to complement the data set that was published by the government. So I could add that README, and you can see as I'm typing here, the UI lights up. So effectively what it's saying is I've now staged a change that could be committed and that would add a README component. So the README would be new, and that's why it's showing up as green. We can also do some metadata. So this is not freeform, this is much more structured. And this would, basically is using DCAT, so it can show up in data catalogs and show up in Google's dataset search and things like that. So let's click on the title and let's do directory of business improvement districts. And then for a description, I can actually just go copy it right from the Open Data Portal. I could add to it if I want to, but let's just get something in there that actually means something, so I don't have to try and come up with something meaningful right here in demo mode. I can also add keywords like urban planning, like streetscape. Whoops, that's not a keyword. Let's do streetscape. Let's do NYC. So I can start adding my own keywords. So I mean, this is it. You're basically, you're now looking at a view that, the ability to add metadata that talks about a data set has been the gate-kept realm of the people who maintain open data portals, and we've sort of democratized that. And now, you can actually add these to your own data sets and publish them with the same ease. So you can see now we've got README and meta are now new components, and the commit tab has lit up down here. So if I click on commit, I can now add a commit message here and just say added basic metadata and a README, and I can commit that. And it'll drop us back into history, and now good commits. So we've got the initial commit when we loaded the data set, and we've got one commit with a nice message here that says where we added metadata. And as we explore this view down here of the data set, we can see what it looked like during this commit. So README and meta were new, and if I click on the original one, the structure were new. So the next thing I can do is edit the schema. So if I click here on structure, I could change the name of a column, or I can add a description to that column. So if I click on my body here and I see organization name, so org_name is the name of the column, but let's add a better description for that column and say the legal name of the bid. And you can see, same thing. As soon as I start making changes, the UI is letting me know that I'm ready to commit because there's actually a difference now. So I could add another one here for, oops, I used the wrong field. So this will just be a unique ID assigned by, and I'm not sure who assigns that, so I'm going to leave it blank, and we're not going to publish this, or if we do publish it, we'll take it back down immediately because I don't want to share bad data with the world. So I'm going to commit this, and I'll do one more commit here and just add another message that says, added some column descriptions. I'm crafting this data set and making changes as I go, and I'm leaving a little breadcrumb trail for anyone who wants to follow along and see what changes I've made, and now I've got 3 commits. So you can see the process we're going through here. And last but not least, I want to do a body edit. So if I click on body, we can see the body table here. We're very close to being able to just click on here and start editing and start typing, but we can't do that just yet. So what I can do actually is just drag in a new version of the same CSV, and it'll basically stage that as a change to the body. So here's my original CSV. I'm going to open it with a tool called Table Tool, which is just a Mac CSV viewer or / editor. And what caught my eye about this data set was this column called org year, which you can see here. You can see here is some of an actual year, and some of them have a month plus a year. So I'm going to simulate cleaning up this data set and saying, nope, I don't care about the month. I should store it in another column, but I know people can put the original if they want to, but I'm just going to turn this into a year column because it suits my purposes better. You could argue that I'm removing value from this data set. I guess it depends on your point of view. So pretend I'm editing all of these. I'm just going to do 5 for now. And I'm going to save this CSV. So this is saved on my desktop still, but what I can do is drag this right into Qri on top of the body. So it's basically read my new CSV or my newly saved CSV, and it's comparing it to the previous commit body. And then if I commit, I will just say cleaned up some values in the org year column, and we'll hit commit. Okay, so we've gone from, now we got 5 commits. Sorry, we have 4 commits now. And this last commit, we see a body change. So we didn't add a new component here. We actually modified an existing component, so it's showing up as orange instead of green. But that's basically our full process here. And we can see, if we inspect the body here, that my org years are actually just years, which is what I edited. So now they're in Qri. And last but not least, we want to actually I'm going to change the name of this data set right now. So it just says Directory of Business Improvement. I'm going to call it Business Improvement Districts. So it's the full word. So all I have to do is click on that to change it, and it renamed the data set. And then last but not least, we have this publish button. So what this button does is going to take my entire, it's going to take my full data set with all of my commit history, push it up to Qri Cloud, and then you'll be able to, with one click, clone this entire history of events down to your local machine and inspect it. So let's hit publish. It's giving me a warning that this will be public on the internet. And just like that.
Drum roll. Yeah.
All right, so that publish button turned into a view in cloud button. If I click that, you can see we've got a nice URL structure up here, qri.cloud / my username / the dataset name, and we can see the meta. We can see the body preview and take a look at the dataset and decide whether we want to use it. But I can now copy and paste this link and fire it off to a friend. The other thing that we are able to do is if you click on my username here, this is basically my personal open data portal. So now I can share this, and this is discoverable, and anyone who is interested in what I'm working on can come to my Qri Cloud profile and see the stuff that I have most recently committed and pushed, which is probably topical and relevant, and is what I'm jamming on these days as a data person. So that's our Qri demo. I can turn it back over to the group for questions, or I can show anything else that anybody wants to see. We can also do diff. Do you want to do diff?
Yeah, sure.
Okay, so while I still have the reins, so we have this little compare view tab over here, and this is still pretty nascent, but right now, in the future, you'll be able to choose 2 bodies from different data sets that you have. In Qri right now, it only works with CSVs, but it's more of a demonstration to show that the differ is working, and we can visually show you a diff between two data sets. So you saw that I made a change to the CSV. So what I'm going to do is I'm going to download the original one from the Open Data Portal of New York City again, and then we're going to compare the version that's on my desktop with the version that we just downloaded. And you should be able to see those value changes where I was removing months from the columns or from the organization year. So let's click on this before view. Let's go to downloads. Let's go to downloads and let's find Directory of Business Improvement Districts. If I can click on it, there it goes. Okay, and then what I want to compare it to is the changed version that's on my desktop. Let's go to Chris Wong desktop. And here's my changed view. And just like that, you can see it says +5, -5. So there's 5 changes here. If we scroll over, here's the diff, right? So I can actually see individual records that have changed here and what the previous value was. So this was January 2019, and it's now 2019, and so on. Putting, and we're visually showing you that the diff has changed. If I click on collapse, it's only showing me the new version, but it's highlighting those that were changed. And if I click on the little red hash here, I can actually see what the detail of that change was. So I can collapse or I can do all changes, but that's it. And Brendan is cheering. So this is what we've been working towards for a very long time, and it's here and it's real. And the next iteration, we're wiring it up to the sets that we have in your Qri collection.
Amazing. Thank you, Chris.
All right.
Yeah, so I want to take any questions about what Chris has demoed or didn't demo that you saw or flew by fast, or what features you'd like to see. Some are coming through in the chat, which is nice.
Chris, do you mind click share while we take questions?
I lost my ability to remove sharing. I don't know what that is. Here we go. Oh, there it is. Okay, stop share. It was hidden behind my preview. Thank you.
Any questions in the crew?
This is so much nicer than the earlier Qri Desktop. Great work.
Thank you, Kelsey.
I mean, that, except for I can't log in on the new one, so I need to figure that out because that's been going on for a couple months.
Oh, no.
Yeah, Kelsey, we should figure that out. Maybe if you want to stick around after the call, I can help troubleshoot that.
All right, cool. Well, we'll get to data stories, which I think will be Chris again. Maybe later in the chat, we'll give him a little break. But I thought the next thing, we'd turn it over to the folks who have other things to do with their lives who chose to join. Kelsey, do you want to tell us a little bit about what you had in mind and for using Qri or what we could help with?
Yeah, so I can tell you the project we're working on right now. It's a Jupyter notebook that takes enforcement and compliance history and lets you put in your zip code, or shortly I think we'll be putting in congressional district, and it pops up a map and basic statistics around what emissions are permitted in your area, what industries those are permitted to, what it means to have those things allowed, because it's literally a permission to pollute. And then also it'll show which industry or which particular facilities on the map are out of compliance or have been out of compliance in the last 3 years. And we're taking this to some activist hubs and also to some sort of university libraries for public engagement, so people kind of have a better idea of basically EPA is failing to do enforcement on violations right now, and industries are kind of running away with it, and that's something we're able to prove, but like the point of this is to make it really tangible. And there's a couple of different things that bring me to Qri for this, which is a very silly one, which is like so Rob told me about Jupyter, Google's Colab, which is just a really easy way to put a Jupyter notebook online. I'm honestly relatively new to using Jupyter, so I'm sure it has a ton of features I'm not even aware of. But one of the things that's necessary is for the data to be available online, but the exporter file from Echo, which is the last 3-year history, is too big to keep in, for example, well, basically anywhere. Right now I have it on Git LFS, which is, it's one commit and it's over our limit. So it's not a great solution. It literally should not work according to Git's terms, but it is working right now.
How big is the file?
I don't remember.
It's
but
like
I'm wondering, like, it's not ridiculously big. It's just bigger than GitHub wants to give everyone, right? Let me find that actually. But I'll add in the chat in a sec. But there's a couple things too. Like, one is that this is updated on a quarterly basis. So to get years, you have to update it every quarter, which would right now involve like, I think we're already out of date with our current Git LFS thing, and I don't know if they're going to let us do that twice. Then there's also stuff that gets updated more regularly than that. And then the other thing is Edgy being edgy and very interested in not just the last 3 years, but like what was the impact of the Trump administration versus the Obama administration. There is data going all the way back to 2002 with much more details, but it's separated into Clean Air Act and Clean Water Act and RCRA and all this different stuff. And so there's a need to combine on different columns to try to get a complete database to answer the questions. And it'd be really cool. And I know Qri has transform scripts to take stuff like this and like show with provenance that you actually have all the different pieces of the puzzle in one spot. So I'm curious what parts of this seem sensible to bring to Qri. I feel like the immediate deal breaker would be if there wasn't a way to like link to raw data on the internet and have my notebook pull from it. I'm not super good at handling large data sets, so, and that's you guys' thing. So I don't know what's ordinary to do here other than having a database that isn't just a CSV on GitHub.
Totally. It's a big toughie. This is really interesting. It's really, really interesting.
I was going to say, like, we're trying to attack the opposite problem, which is like, if you run Jupyter locally, yeah, you have all this data locally, so let's just let's expose it so you can pull it into Jupyter with a simple convenience method. But you're doing the opposite, which is like, people don't want to run Jupyter locally. I actually teach a class where people with Google Colab in it, and the hardest thing to teach people is how to host a CSV, which basically means putting it in Google Drive, and then you have to like hack the URL in order to get like an actual downloadable link that a Jupyter notebook could parse in. So I feel your pain, but I'll let Brendan respond on like what's the feature we actually need to get that to work.
Wow, Kelsey, thank you for the to the byte level description of what we're looking at here. 1.45 gigs. Yeah, that's it's a non-trivial amount of data. But it's also like kind of a trivial amount of data. It's like, right, and this is a really interesting time for us because we've recently had people try to put they've like tried to put 1 gig data sets into Qri and sort of complain about the performance of it. And so for that reason, we've been spending some time working on performance the last little while. Right now, on a relatively fast machine, it takes about 50, 60 seconds to put a gig of data into Qri. And we want to bring that down. That's just additioning, adding data. Now we're talking about sort of hosting it and moving it around. You sort of have the fundamental problem of like, Google Colab is operating on a sort of centralized system, kind of like we could. So like there are solutions here that we should explore. I'd love to sort of like have a conversation about this because like this is a really interesting side to things. Like we definitely, okay, so options that we can do something nice and sweet because you're edgy and you're part of the sort of like origin story of Qri. And so like we would just do this for the sake of making it work. Now, how would we answer that in a way that would sort of like scale and be a service that we could actually offer is a different question. I would really love to live in a world where someone can be versioning this and putting it on a just decentralized network, and we can be hosting or the throughput for accessing that file. So we could sort of serve up the stable, like Query Cloud could be the stable access endpoint for that, the same way that an IPFS gateway works, but a little more, but with giving you sort of the niceties of versioning and stability around the audit trail. I think that would be the solution that I really love to see us sort of arrive at, but got to think more about it. ColorOS, very interested. I think that the 1.5 gigs is like perfect for the performance tests that we're trying to make work right now. But that's kind of across the board, not just sort of adding, also just like publishing and moving around. Like 1.5 gigs is enough that that's pretty tough. It's tough to do in a way that feels snappy. It means that anything that you've done that's kind of like a little bit hacky along the way is no longer going to work, or it won't work in a way that'll be consistent. Which is a great chance to shout out to Rob, who has made a lot of our command line tools work a million times better this week. Thank you, Rob, for your contributions. Because part of the things we've been talking about is just that, apologies if you hear a train in the background. One of the things we've been talking about is like, we need progress bars for that kind of stuff, right? Like if you're going to push 1.5 gigs around, you need like a clear indication of how far along it's going, and ideally a way to resume if it only works our way, which a lot of our sort of transfer mechanisms have internally. So yeah, I'd be really interested in understanding this and how this workflow might look and feel. I think we'd need like at least 45 minutes to sort of hash out a plan. But I'd be very interested to hash that plan out, record it, and put that information back out if you're okay with publicly sharing what we find. Yes, the rest of you, Rob, is Strogrog. Sorry to ouch you, Rob. Is that okay?
Oh yeah, that's me. I was just going to ask with respect to this. You can install third-party packages on Colab in Python, right?
Mm-hmm.
So not remotely a short-term solution, but like it certainly seems like a good long-term thing for Qri to have is a Python package that is just links to the Go binaries that would allow you to like pull in a data body or some part of a data set.
Deeply agree. Yeah, we've resurfaced that in a big way. This go around as a thing. We've actually, as we've had the data research assistant team sort of spin up, we're seeing a lot more interaction between Jupyter notebooks, and that's like we just need to get that story a little cleaner. And if you have a package, maybe that gets us this like escape patch that maybe through that Python package we can actually spin up some DWeb stuff. I don't know what that looks like. I'm assuming that things are going to be pretty locked down in terms of what you can do in a Colab cell, but let's find out. Can we spin an IPFS node up in a Colab cell? If we can, then I'm all for that. But for others that I'm making a reference. I know there are people who are joining the call for the first time. So IPFS stands for the Interplanetary File System. It's a way of moving around files in a decentralized manner. It also is like a peer-to-peer thing, and so it needs its own little binary. It needs to run up and spin up a peer-to-peer network. And so there's questions about where it'll work. I do want to take some time to share something, but I want to make sure there's room for questions, if anyone, because like Chris gave the demo of like pretty much where we're at in terms of state of the art for our latest release. And so if there's anybody who has any other questions, I'd love to chat.
Yeah, in particular, since we had put the bat signal up for the New York Healthcare/AI group, if there were questions from participants with respect to that, I definitely want to make sure we answer those, because that might be the only reason you're in the chat. So Harpal and Mark, let us know either through the chat or unmute yourself if that's possible, if we can answer that. Otherwise, yeah, I think P5, we can turn it over to you.
To that end, just before this call, I did work through the Johns Hopkins COVID datasets. I'll just take over screen sharing. And again, feel free to drop questions in chat. But Johns Hopkins does have like a pretty nice thing on GitHub that they're releasing. I thought it'd be a really nice starting point and nice. So yeah, I'm going to share a screen really quick. I'm going to choose screen 1. Sure, I guess. Hopefully everyone sees this. Yeah, awesome. Cool. Thank you for the thumbs up in chat. So yeah, this is just the COVID confirmed. I've split them up into 3 data sets, 1 each. And this is just looking at the time series of each. And so this is, and we have some funniness in the columns that I'm going to clean up. And yay for version control. You'll see better column names in a second. But we have the confirmed, recovered, and deaths for each in a time series. And so this is actually sort of like province or state, province or region, the latitude, the longitude, and then as a 1 column per day time series. So every day this gets 1 column longer, which I find really interesting. I think this is like not the right way to organize data, but I'm not the one who did that. But what's fun behind the sort of scenes is this is being wired up with the transform script. And so like the actual script itself is in, if I pop up, geez, is Qri Desktop gonna work for me? Let's find out. I do weird things to my machine. And so sometimes Qri Desktop is not as nice to me. But to give you, oh cool, it's working, great. So if we look at this one has a special extra component that we're talking about a little bit of, called a transform script. And what this is Python code that lets you sort of script this thing. And so in 9 lines, we've made a script that downloads from the Johns Hopkins GitHub repo, pulling the exact file in and sort of making this into the data set that you're seeing. So just to quickly walk through this script, we're loading a special package called HTTP, which is going to let us do HTTP calls. We have a URL that I've just defined so that it's like a little easier to see. This is the confirmed URL, and we can sort of see this is the actual time series of confirmed stuff. If this ever changes, the script will break, and I'll have to update the script. Then we have these 2 functions, download and transform. Download, these 2 will both be called by Qri when we hit save. And so if I make a change to this data set and I hit save and I have a transform script defined, Qri will run this for us. And anything that we do that changes the data set becomes part of the commit. And so this is how we sort of have this like nice audit trail on how to, what this proves is like, it doesn't prove, but adds a lot of, a high degree of auditability to, is that when this thing ran, it downloaded from that URL, and then we returned the body. And then in this area, this function called transform is the one you always define. It's just like a main function. And what happens here is we're saying set the body to the result of the download. So ctx.download is basically this function gets called first. It goes and gets the data, and then ctx.download is where the data goes to when this function is done calling. And then we're saying parse this as a CSV because we know it's CSV data. Cool, done. And now we get a body that looks like this and has all kinds of great stuff in it. The other thing that we've been getting a lot of requests for recently is sort of like, we've really worked on this sort of like transform scripts, and we started with Python as a, because we really wanted to be able to sort of tell this story around data cleaning. And we thought it was really important to like, and also like automating of data ingest. We've been getting a number of questions around data querying, and this is like the sort of other side that we constantly get questions around. And so today I want to demo something that I can only show on the command line, unfortunately, and this is like very, very sort of, this is definitely not in production and definitely not like merged yet. Actually, the team hasn't seen this yet either. But anyways, let's just cut to the chase. We think that this might be a possible thing that is doable. I don't know if you can see this, but what I'm saying here is I'm going to say, basically, I want to be able to run SQL against data sets. So I can do, basically, I have this data set that is country codes, which if anyone wants to see the data set itself, it is a data set of country codes, which gives you this nice list of country codes in their official name in different languages, which is quite nice. And it also gives you the ISO code, which is a really helpful thing for other sort of tools. So we actually use this data set in a transform script to calculate the World Bank's actual population. So if you look at the World Bank populations data set, we use this data set to figure out the actual list of real country codes. But one of the things that you really want to be able to do is you actually just want to be able to run SQL on it. Well, it works. We've sort of like been dealing with this like select queryable thing for a little while now. And so far, it's been so long that we actually wrote a paper like 3 years ago about running SQL against data sets like this in a sort of like transactable, mutable way. And at Qri, we've really wanted to get back here for a long time. The problem has been that the actual like version control, managing and moving around of data has been such a massive challenge that getting something like this to work has actually became a side project. We said, okay, or got pushed to the back burner. We said, we don't want to be able to do querying on data sets. We're going to wait until we can actually do versions right, and then we'll get back to querying. well, things have kind of stabilized enough that we're now working more on performance inside of Qri. But another thing has happened along the way. If you sort of try, this is a bit of a side tangent, but inside of the Go ecosystem, we've had this project for a long time called Vitesse, which is a project by Google. I just want to do an open source shout out because it's important to sort of show where we're coming from. But Vitesse actually wrote a SQL parser a long time ago. And so our efforts, we have like an old effort here that was based on the paper. I think it's called Dataset SQL. I don't remember. This repo is like, if it exists, it's so old. Yeah, like last time it was worked on was 2 or 3 years ago. And so we actually took a big stab at doing this ourselves. And this became too heavy a lift with everything else. Somebody else came along and wrote this amazing package called OctoSQL, which is, I would like shamelessly plug and promote this package because this lets you run SQL against all kinds of stuff like Redis or Postgres or CSV files or JSON files or anything. And that's actually what we're looking at here. We've just taken that and wired it up to Qri so that it's natively part of the tool. And so this is, I can actually use all of OctoSQL's cool stuff. So I can actually take this exact same thing and do format CSV, and I'll get that exact same thing as a CSV file. It's a really convenient thing to be able to do that as JSON, whatever we want. I can pipe that to JQ. Fun stuff, like we can actually run SQL queries against this. Where I think this is really important is we're talking about doing this sort of like, or where this really becomes useful long-term is we have these 3 COVID data sets, right? Talking back about what do we actually want to be able to do with this. We have these 3 data sets that have the same shape. And so what we should really be able to do is do types of queries that join these things together. And so that's the kind of stuff that we're hoping to shift in the very near future. But yeah, I think the querying is something that we can achieve in the short term, not the long term, mainly because of the wonderful world of open source and being able to sort of like benefit from people doing this great work. This is such phenomenal stuff, and it's one license that allows us to build it into our tool. And so I think it's awesome. Any questions? Ideally, Rob, this gets you to the point where we can now actually do the join data sets that we talked about 8 months ago, 9 months ago.
Yeah, that's just what I was thinking when I saw the SQL naming it just the data set name as a SQL table. That's awesome.
Yeah, and so I think I'm really excited about this, and I think the first thing I want to do is like use the real world sort of COVID data sets as a test ground. I want to be able to run a union against those 3 tables that joins on a given sort of like country selection. Can I do for a given date in a given country, can I just get confirmed death and recovered? And that would mean unioning those 3 tables and doing subqueries against all of them. And all of that looks like it's very, very much doable, which is an exciting thing. To lay the roadmap for this, we have always imagined that SQL would be the other type of transform syntax. So we have Starlark, which lets you write Python code, but then you want to be able to sort of query that. And so you can see a world where in the desktop UI, you're just like able to run SQL queries, and that's like nice exploratory data analysis work. But then if you craft a really intense sort of query that joins together a bunch of data sets, we can make that as a transform script and run that query. And that way it will track all of those data sets are, when they update, you need to rerun that query and it will tell you, okay, cool, you need to rerun that join to get the latest version of a data set. And so in the COVID example, it would be really nice to do just against Johns Hopkins. We can do, the 3 data sets, do the join, and then anytime any of the 3 update, we'll do the update the one that sort of downloads that joins them together. But we could also start to see like comparisons from other sort of competing sources of data, right? Like the Johns Hopkins COVID data set is by no means authoritative, or like canonical, I should say. It's authoritative. It's as authoritative as the school is. But like we're seeing different numbers coming out of different places, and being able to do queries that sort of compare some of those numbers would be really interesting and valuable. And being able to save those queries as union data sets is, I think, a really, really exciting world to live in.
And the crowd goes wild. Wonderful.
It's really fun. It's really fun when other people do really great work. This OctoSQL project is incredible. The work they're doing is really, really good. And it's built on the same test thing. Rob, what was your question?
Rob was about to say something, it looked like.
Oh, no, sorry. I should stop waving my hands around. That just made me think of another site that I was going to try and look up that is I think is scraping all the state agency sites for numbers. So it'd be interesting to see and then they post it automatically to a Google Doc. It's publicly visible, so you can see it as a spreadsheet, so different tabs have different kinds of info. Might be a interesting use case to look at, or like a comparative thing to compare, or like could this be reproduced in an easier way if the data were coming through Qri?
Oh, that's really exciting. That's really, really interesting. I'd love a link to that, any of that work. It would be really nice to. If not, I'm just going to go frantically Googling myself to try and figure out what you're talking about. But cool. Any questions? Anything else? Any other stuff? I definitely want to follow up on the Echo stuff, Kelsey. I think we should schedule some time to chat about that. And by schedule, I mean like I'd love to talk really next week if you have time. So yeah, and ideally we can fix your query repos. So if you want to stay on after the call, we can fix that. But yeah, I'm really excited about SQL. We've been wanting to get it in for a while. Ideally, we can get that in. COVID tracking. Perfect. Thank you. I think it's doable sometime soon. I don't know, probably 3 to 4 weeks it'll be in a release. But we have to talk with the team about whether that's a high priority right now or not. Anyways, cool. Rico, do we have anything else on the agenda?
No, I was going to, anything else on anyone's mind? Open forum, user forum.
Sure, I posted that link in the chat. I do have a completely oddball question.
Yeah.
Which is, since I was working on all the command line docs, one thing that I was hitting is, it just made me think of it again when Chris was going through the slides, all the different sort of pieces or components or sections or elements of a data set have been referred to by very different terms in different docs and different parts of the code base. So I was trying to figure out what I should actually be calling those, or if there is some consensus on what those should be named right now. This is probably not the right forum to discuss it. So if there's
why don't we cap off the meeting and then we can move into discussion there. But yeah, lots to talk about there. Generally components, we just call them one component. Yeah, so Rika, do we want to kill recording?
Yeah, all right, that was it.
Thanks so much, everybody on the internet. You're great.
Recording ending in 3, 2, 1.